Today's section is 3.1 and we're going to look at vertex form. So this is going to take you back to Algebra 2 and hopefully you remember some of the key points that we need from here. So one little bit of a refresher is just the two different forms we have for quadratic equations. The first form is standard form where it's ax squared plus bx plus c. Okay, typically we have that set equal to 0 when we're trying to solve it, but right now it's our function, so it's in function notation f of x. Vertex form, which we just looked at when we were looking at the transformations of various parent functions, but it's f of x equals a times the quantity x minus h squared plus k. All right, and where it says a cannot equal 0, because if a equals 0, we just end up with a constant function. All right, so let's take a look at our first example. It says, write f of x equals 2 times the quantity x plus 2 squared minus 3 in standard form. So they gave us the equation in vertex form. We want to write this in standard form. This is the easiest of the two ways. So whenever we're in vertex and we want to go to standard, all we have to do is simplify. So just be careful simplifying. Remember order of operations. I need to take care of exponents before we multiply. So that's 2 times x plus 2 times x plus 2. So 2, once I FOIL those two, I get x squared plus 4x plus 4. Don't forget that minus 3. Now I need to distribute the 2. So I get 2x squared plus 8x plus 8 minus 3. And then 2x squared plus 8x plus 5. And voila, we're done. Standard form. So that one is pretty straightforward, fairly simple. Just don't make small errors. The next problem that's going to be your favorite one of the day. And that is wholeheartedly sarcastically. So it's not bad, just make sure you're paying attention. So example 2, it now gave us an equation in standard form and asked us to write this in vertex form. So if you think about vertex forms, let me write that down here. We have a perfect square trinomial. Okay, we have this perfect square trinomial here inside of the vertex form. So we have to create. There's no perfect square trinomial there, so we're going to have to create that. So this process will sort of remind you of completing the square. Okay, but when we complete the square, we're trying to solve for something. In this case, we're not solving, so I'm going to add something, but I'm not going to add it to both sides. So just pay attention to the process we follow. The other thing to remember, I guess, before I get started, is when we do complete the square, we do not like there to be a coefficient in front of my x squared term. So we do also have to take care of that. And that's the first thing, well, actually the second thing I'm going to do. So the first thing I'm going to do is group my first two terms together. I'm going to group those x terms together. So I'm going to do 2x squared plus 8x, close my parenthesis, plus 7. Okay, so I'm grouping my x terms together to start the process of finding that perfect square trinomial. Now's where we don't like that coefficient in front of our x squared terms. I'm going to factor it out. 2 and 8, they're both divisible by 2. So then I'm left with x squared plus 4x. Okay. Typically I'd be done, but since we have to do that completing the square process, I'm just going to go ahead and write my plus blank there and close my parenthesis. Don't forget your plus 7. Okay. So here's where we have to think a little bit. If I add something to the right-hand side of my equation, I would typically have to also add it to the left side of my equation. But on the left side, there's not a value. I'm not solving, so I can't add something to the left when I'm not solving this equation. So to combat that, we sort of have to think, okay, well, what would cancel this addition of this blank? Well, if I subtract a blank, and it's going to be the same number, I just have to find it, well, now that's canceled each other out. And typically it would, but remember I factored out this 2. So if I were to go backwards and distribute the 2, my blank is now being multiplied by 2. So to combat that, we have to multiply that blank by 2. And now we're good to go. Now we can just figure out what should be in that blank. So this is where it's the same process. Say, okay, what's my b value? Well, my b value is 4. My b divided by 2 value is 2. And then if I take that b divided by 2 value and square it, I get a 4. So that's what I'm adding here, and that's also what I'm subtracting there. Okay. Just don't forget this little 2 out there. That's what a lot of people forget. So now, right inside of here, I have my perfect square trinomial, which is your x and your b divided by 2 value, which is a positive 2, so that is x plus 2 squared, plus 7 minus 8, so I get 2 times the quantity x plus 2 squared minus 1. And just like that, we have it in standard, or sorry, not standard form. We went from standard form to vertex form. Okay, now if you wanted to check this, all you would have to do to check this is just do what we did in the last problem. I'm going to FOIL that, which I know is x plus 2 times x plus 2, so I know that's x squared plus 4x plus 4 minus 1. So then I'm going to get 2x squared plus 8x plus 8 minus 1, and we get 2x squared plus 8x plus 7. And if we look, it matches what we started with. So yay, that's good. We did something right. Okay, so I will work through the your turn. I'm not going to say anything, but that way if you guys get stuck, you can look back at the steps. So since I factored out a negative 2, I almost forgot I needed to multiply by that negative 2. Forgot my negative. I shouldn't have written it so far away from my number. So that is your answer then. Well, I guess not quite. That's your vertex form, but they did ask for the actual vertex. All right, moving along. Went too far. So write the vertex form of the equation for the parabola whose vertex is 1, 2, and passes through the point 0, 0. So I'm going to go ahead and write down my vertex form. So vertex form is y equals a times x minus h squared plus k. All right, my vertex is hk. An ordered pair is just xy, so substitute in everything I know. So pretty much to write an equation in vertex form, I need hk and I need my a value. So we're going to solve this for a. So negative 1 squared is positive 1. Whoops, I forgot to put my k in. There we go. So I'm going to subtract 2 from both sides. So a is negative 2. So my final answer is y, or I guess I should say f of x, equals negative 2 x minus 1 squared plus 2. All right, so you can pause the video, work on the your turn, and then come back and check your answer. All right, and the last problem from today is our math story problem, your favorite and my favorite. And it says a baseball is hit at a point 3 feet above the ground at a velocity of 100 feet per second and at an angle of 45 degrees with respect to the ground. The path of the baseball is given by that function, where f of x is the height of the baseball in feet, so y is how high it is, and x is the horizontal distance from home plate, also in feet. It says, what is the maximum height reached by the ball? So the maximum height reached, that is my y value. So I have to find the y value for that vertex point. So let's think about this. If I'm looking at this equation, it's going to be a parabola that is going to open down because it's negative. So it's going to look like this, which makes sense, should make sense, because the ball is going to reach a certain height, the highest point, and then start to descend. So I'm just going to find this vertex point like normal. So the first thing we have to do is find our vertex point, and that is x equals negative b all over 2a. So negative 1 all over 2 times, which gives us negative, well, they're both negative, so let's go ahead and make that a positive, 1 over 0.0064. And when we simplify that, because we don't like a decimal inside of a fraction, we get 156.25 feet. So that means the ball is just over 156 feet from home plate when it reaches its highest point. So now we actually have to find the highest point. So now we have to find the y value. So here's the fun. Just substitute this in to the original problem. And solve. So once you go through, do all that work, you should get 81.125 feet. Okay, so that ball, the highest point of the ball is just over 81 feet high. Okay, you could also have done that in a calculator like we did, and I believe it was the last chapter towards the beginning. So for the your turn, you can go ahead and pause it before I write this down, try it, see what you get. Be careful, you need to determine, do they want the x value or the y value? I'm going to give both, and then I'll tell you which one. So this one, it says how many units should be produced in a day to yield a minimum cost. So that means they want the x value, because the minimum cost would be the y value.